Okay, hey everybody, welcome to the first E-Day lesson for chemistry. This is the first part of a two-part series on oxidation reduction reactions. We would normally do this at the end of the year, but it's enough of a standalone topic that we can pretty much do it at any time. So we're going to go ahead and go through some things. There'll be an assignment on Learn, and every one of your teachers will have office hours, but this will be the video that goes along with that, okay? First of all, what does redox mean? Well, originally it meant that oxygen was combining with something. So if you had the oxidation of iron, for example, to make iron 3 oxide, that would be oxidation. All right. We now know that it's a transfer of electrons. So anytime electrons are being transferred between elements in a reaction, that's a redox reaction. This particular thing, Leo Gur, will be really important in the second half of this. So today's lesson, we won't worry too much about Leo Gur, but in the next one, Leo Gur is going to be really important, so you might want to be able to come back to this, but I'll mention it a bunch more. This basically means lose electrons oxidation, gain electrons reduction. So anytime an element loses electrons, it's been oxidized. Anytime an element gains electrons, it's been reduced. We'll come back to that, but we need to do something else first. So one of the really important goals today is to do what is called oxidation numbers. Now, we've kind of lied to you so far this year. So if you look at this particular periodic table, you'll notice they've left off most of the transition metals in the middle. We've kind of simplified this for you, and it's actually going to be a lot more complicated. So we've always said, okay, group 1A elements, those are the alkali metals. Those are +1. The alkaline earth metals, that group 2, those are +2. Boron's family +3. Carbon ±4. Nitrogen -3. Oxygen -2. Halogens -1. And then the noble gas is 0. That's a simplification. It's actually a lot more complicated than that. And so these charges for all of these elements that we've been talking about all year, those are called the oxidation number. Now, it turns out that depending on where you are in the periodic table, they can have more than one charge. Now, you've already seen that in the transition metals. So, for example, we talked about iron 2 and iron 3. It either had a +2 charge or a +3 charge. Copper could be 1 or 2. Lead could be 2 or 4. Tin could be 2 or 4, and so on. But it turns out that all of these, a lot of these guys in this area of the periodic table, particularly the non-metals over here, they don't always have a -2 charge. They don't always have a -3 charge. It's going to depend on who they are with. So what we need to do is be able to assign oxidation numbers. All right, and there's going to be a series of rules. You're just going to have to know them. On the final that we take at the end of the year, there are definitely going to be some of these. So it's really kind of an algebra thing where you try to figure out what everybody's charge is based on these rules and some other things. So let's get started. First of all, hydrogen is usually +1, and if you've taught, if you had me in class, you've heard me say over and over, chemistry is the science of exceptions. The only time hydrogen's not +1 is when it's a metal hydride. It would be -1 there, but you don't have to worry about it. 9 times out of 10, even more than that, hydrogen's +1. So as far as you're concerned, hydrogen's +1. Next one, oxygen's -2. Again, it says usually. The only time it's not is in peroxides. So hydrogen peroxide, it's -1, but you almost never run into that. Okay, so as far as you're concerned, when you see oxygen in a compound, it's automatically -2. Really important one. Any element in its uncombined natural state is 0. So if you have calcium metal, if you have iron metal just by itself, its charge is 0 when it's by itself. Even your diatomics, chlorine gas, Cl2, even though that's diatomic, its charge is 0. Okay, so any element in its uncombined natural state always has a charge of 0. Good news is group 1A is what you'd think. Everything in group 1A, those alkali metals, that very first column on the periodic table, they're always +1, and along with that, group 2A is always +2. Okay, so those are what you'd think. None of that's any different. Here's where you got to really pay attention. The total of all the charges in a compound must equal the charge of the compound or the ion. And I think you'll see what I mean in a minute. But basically, they all have to add up to equal 0 if it's a neutral compound, or if it's a polyatomic ion like phosphate is PO4 3-. When you add them all up, it would have to equal 3-. Okay, so you can see this is kind of additive and subtractive. It's basically algebra, kind of entry-level algebra. So let's do some. Now here's the downside. My computer, Moby is a program that I can write on the computer. I could actually show you writing. What I'm showing you on right now is called Snagit. Well, they're not working together. So anytime I try to do them at the same time, they fight. So I'm going to go through some of these examples. I'll try to be as slow and as clear as I can be. But there's also a YouTube video on Learn, which there's a link to that. So you'll be able to go there. And that guy has some different technology, and he can actually show you the writing. But I think this will be good enough. All right, first one. One thing you're going to need for this, by the way, and I would pause this video if you need to, a common ion chart and a periodic table will really help you here. But again, knowing those rules is what's going to allow us to do this. All right, so if you can get a periodic table, that'll help you. First off, all right, we have KMnO4. This is potassium permanganate. K is a group 1A element. All right, it's in that first column, so based on the rules, you know it's +1. So if I could write here, I would write +1 in parentheses directly above K. So we know its charge is +1. Oxygen, based on the rules, is -2. So above this, in parentheses, I would write -2. Then there are 4 of them. Okay, so if you look at this algebraically, you know K is +1. You know oxygen's -2, and there are 4 of them. The total negative charge due to oxygen is -8. +1, -8. There's no charge up here. This is a neutral compound. So what does manganese have to be in this compound? The answer is +7. So you have +1, you have -8. This needs to be +7. So in this compound, manganese is +7 charge, and you would write that above manganese in parentheses, +7. All right, let's look at this one. This is sodium sulfate. All right, Na2SO4. We can go right through the rules to figure this out. Sodium, because it's a group 1A element, is +1. There are 2 of them, so the total positive currently is +2. Oxygen again is -2. There are 4 of them, that's -8. So we have 2 plus total, we have 8 minus total, therefore sulfur needs to be +6. So the oxidation state of sulfur here is +6. Here we have calcium dichromate. Gets a little trickier here. Calcium is a group 2A element, so if you find it on the periodic table, you'll see that it's group 2A, so that's +2. So we know right off the bat this is +2. Oxygen -2 again. This then is a -14 charge. Currently we have -14 total. We have +2 total. The difference is 12. There are 2 of them. So each chromium in this compound must be +6. So again, this all adds up to 0 because none of these compounds so far have a charge. They're not polyatomic ions, they are neutral compounds. What happens if we have a charge? All right, well, this is the nitrate ion. This is a polyatomic ion. If you look on your common ion chart, you'll see it on there. All right, but same idea. We know oxygen is -2. There are 3 of them, so this is a total negative charge. Now here's where it gets different. When you total all these guys up, this has to equal -1. It all has to total equaling -1. So if this is -6, what does nitrogen need to be to total -1? And the answer is +5. So normally in the past we've said nitrogen's -3. Well, yeah, it can be -3, but it can be all kinds of other ones. That's the point of this oxidation state, and in this case nitrogen's +5. Here's ammonium. All right, you've seen this before, another polyatomic ion. When you total this all up, it must equal +1. Hydrogen, as we've said, is +1. There are 4 of them. This is a total of +4 charge. All right, so above hydrogen, you'd write +1, but there are 4 of them, so that's +4. When you're done, it has to add up to +1. Therefore, nitrogen needs to be -3. As you can see, there's more of them. I don't need to go through all of them, I think. You might want to double check those and ask your teacher in class so you can go do these on your own. So 6, 7, and 8 on here. I will warn you, number 8's a little tricky. You got to think about what the charge on chromate is to figure out the charge on lead. And then when you try to figure out chromium, really just look at the chromate ion. Don't worry about anything else. Just look at chromate ion. But if you get a chance, you might do 6, 7, and 8 on your own and then go talk to your teacher. Now, when you go on Blackboard, so I don't know how everybody's individual stuff is going to look, but when you go on there, there is an assessment. Okay, so if you go into my particular class, you will click on E-Day 1, that's oxidation states, that's what we're currently doing, and you will click on this assessment. So if I pull this up, there are a number of problems for you to do, and you can cross-reference this video to try and figure out what all these answers are. Any element in its free uncombined state. So this is all from that PowerPoint. Here are some different problems for you to do. Now you'll notice in the ones that I did on the video, I was giving you the charge of everybody. In these, it specifically just wants the charges of the ones they mentioned. So in this case, I just want to know the charge of H in HNO3. I just want to know the charge of O in N2O5. I want to know the charge of Cr in Cr2, or sorry, K2CrO4, and so on. You have two ways that you can submit this. You can either print this out and fill the answers in physically and bring it to your teacher, or you can go when you click on this, you'll get a page that looks kind of like this. There's right here where it says assignment submission. You will click on this text submission box and it'll bring this up, and you can just number them and answer them right in here and hit submit, and you'll be good to go. All right, so hopefully this helped you. You will need to watch this video. Like I said, there's another YouTube video where a guy can actually write on his machine. Hopefully I can fix that by the next time. All your teachers will have office hours. Those are going to be teacher specific, so make sure you contact them. And then you will need to fill out this assessment and turn it in by Monday, March 10th by 10 o'clock. So you'll have all week. Please let us know if you have any questions. There you go.